We're now going to look at the relationship between the exponential function, which is y equals to e to the x, and the natural logarithmic function, or ln of x. So if you recall, we already drew the graph of the exponential function. So I'm just going to again recap how we drew this graph. So I've chosen values between -2 and 3, and I've substituted these values into the function f of x equals to e to the x. So when we substitute the value of x equals to -2, we're working out what is e to the -2. And you notice that we got the value 0,1353352, etc. Because you recall, e is an irrational number. So in each of the situations, I have rounded off the answers to 1 decimal place. It's very inaccurate, but it just helps me to draw the graph a little easier on the Cartesian plane. So when x is -2, I've rounded off the answer to 0,1. When x is -1, I've rounded off the answer to 0,4. We know that e to the naught is 1. We know that e is 2,7182818. 284, but I've rounded it off to 2,7, and if I scroll down, you see that I have drawn the graph, or the graph of e to the x has been drawn. So the blue graph is the graph of the function f of x equals to e to the x, and I'm going to write it as y equals to e to the x. And it's an exponential function. It has a y-intercept when x is 0 and y is 1. We know that when x is -2, we say the y answer is 0,1. And when x is 1, the value of e to the 1, we rounded it off as 2,7. Right, so I have another graph here. It is the graph of y equals to x, and this is the straight line passing through the origin. And if you notice, each point on this line, x is 1, y is 1. X is 2, y is 2, because the y value and the x value are identical. So when x is -1, y will also be -1. Now, the line y equals to x is going to be my line of symmetry. So I'm going to reflect y equals to e to the x about the line y equals to x. And what happens is when you reflect about the line y equals to x, and I'm going to do this with the y-intercept. So at the moment, my y-intercept has an x-coordinate of 0 and a y-coordinate of 1. And when I am reflecting my graph about the line y equals to x, then if you could, you would draw a line that is perpendicular to your axis of symmetry. And then you would see that the image would be x is 1 and y is 0. So if you notice, when you're reflecting about the line y equals to x, your coordinates change. So in the original function y equals to e to the x, my x-coordinate was 0 and my y-coordinate was 1. In my image, my x-coordinate now is 1 and my y-coordinate is 0. And this happens with each point on the graph y equals to e to the x. So if I look at the x-coordinate is -2 and the y-coordinate is 0,1, and if I reflect that point about the line y equals to x, my x-coordinate will now be 0,1 and my y-coordinate will be -2. So if my x-coordinate is 0,1 and my y-coordinate is -2, this is where the image of that point lies now. So x is 0,1, y is -2. Similarly, if I take the third point that I noted on the graph, when x is 1, y is 2,7, and I reflect it about the line y equals to x, I see that x is going to be 2,7 and y is going to be 1. So this is approximately 2,5, so 2,7 and y is 1. This is where the image of that point lies. Right, so x will now be 2, 7, and the y value will be 1. Now, if we could join the dots, see the shape of the graph. So I only have 3 points on this graph, but this is the shape of the graph. Also, before we talk about the green graph, if we look at the exponential function, we know that the axis of symmetry is the line y equals to 0, or the x-axis. So for my green graph, not the axis of symmetry, I'm talking about the asymptote. The asymptote would be the x-axis. So for my green graph, the asymptote would be the y-axis. Now, let's see what we have done. We were given y equals to e to the x. When we drew the green graph, we've swapped the x and the y coordinates. So x equals to e to the y. But when we're writing an equation of any graph, we always write it in the form of y equals to. So if I want to make y the subject of the formula, you know I need to change this to log format for me to get to y. So y will be the log of x to the base e. And this is ln of x equals to y. Right, so the green graph is the graph of ln of x. I'm going to say y equals to ln of x. So this is a relationship between e to the x and ln of x. If you reflect the graph y equals to e to the x about the line y equals to x, you get the graph of ln of x. And vice versa. If you take the graph of y equals to ln of x and you reflect it about the line y equals to x, you're going to get the graph of y equals to e to the x. We say that e to the x and ln of x are inverse functions.